Hello, everybody. Thank you all for coming out. Really appreciate it. Real quickly, don't forget to fill out your session evaluations, and could you please turn off your noise-making devices? Don't worry about taking pictures of the slides. I'll explain why in a little second here, but welcome to the, crash course for new Unreal Engine developers. My name is Matt Oztalay. I'm a senior technical artist on the developer relations team at Epic Games. And I'm going to try and fit the totality of the Unreal Engine in the next 60 minutes. But before we get started, tell me a little bit about yourselves. So, real quick show of hands, how many of you have shipped a game? Okay, most of the people in this room, great, hands down. Now, how many people in this room have opened the Unreal Engine ever? The new Unreal Engine developers crash course. That was the entire room. Okay, now, hands back up if that was Unreal Engine 4. Almost, okay, that was a significant fraction smaller. Unreal 3? Okay, that's more than I expected, like a few hands. Unreal 2. 1, 2, 3, 4, 5, 6, 7. Amazing. Okay, so I was just kind of curious about that because I wanted to know who comes to the crash course for new Unreal Engine developers. Let me tell you a little bit about myself. I've been in the industry for about 15 years. For the first 10 years, I shipped something like 13 titles on 7-ish different game engines, including Unreal. And I started at Epic about 5 years ago. And my job is to empower Unreal Engine users to push the boundaries of the technology through a combination of exploration, education, and advocacy. And I started using Unreal back in college at Ringling College of Art and Design. I was part of their first class of game art and design students. And back then, if you can think back to then, there were not a lot of commercially available game engines. And they were trying to find something that had a good combination of affordability to the college and usability for non-technical and also a level of visual sophistication. And what we decided to do in January of 2009 was go to Best Buy, buy a copy of Unreal Tournament Black, and install it on all the school computers because that came with the Unreal Tournament 3 editor. It was basically a mod kit for Unreal Tournament. And that's where I started. That was my first game engine. And that was wild to me because prior to that, I'd done some 3D animation. I'd used Bryce 3D, Maya, but I'd never made anything interactive. And it was really empowering for me. I could make my own materials, do my own VFX. I cut my own cinematics, scripted a bunch of interactions. And I'm still flabbergasted to this day. And I love using it because it felt playful. I was playing with the engine. I wasn't working with it. And since then, the engine has grown a lot since I started using the UT3 editor, right? So that was January 2009. Then in November 2009, we get the Unreal Development Kit, which was the freely available version of it that also let you, you could package your own projects, you could deploy to mobile. It started to expand what was possible to all users. And then another 5 years later, we get Unreal Engine 4. And that really opens things up. Now we've got Blueprint, we've got, over the course of Unreal 4, we get a new cinematics editor, we get a host of new features that we're all kind of starting to learn, virtual textures, those were great. And then Unreal Engine 5 comes out in April 2022, and now we've got so much more that we have to work with, so much more that we can do. We've got Nanite, we've got Lumen, we've got all this other stuff, and I imagine that must feel very daunting when you are starting out with Unreal. Because when I started, back here, the expectations were not many. The capabilities of the engine were not a lot, but there was a lot of cool stuff we could do. And now we've got so much more. And I feel like it's kind of like an early access game. I got to start playing the first time it came out, version 0.1. And as the game was developing, I got to help shape the meta. I learned all the new features as they were coming out. But now everybody here is coming into the engine at 1.0, and that's got to feel, I sympathize with that. But I want to talk a little bit about what we're going to talk about today. One of the most important things that I want experienced developers such as yourselves coming to Unreal for the first time to understand is that you can do it. There are no limitations placed on you by discipline or your experience level. And to prove that, And I'm not really going to show you something that is like the grandest scale, because one of the things I want you to get out of this is how to get some easy wins when you're starting out using Unreal Engine. We're not going to be building a cruise ship today. We're going to be building a canoe in our garage, because I think that's an achievable goal. So let's take a look at the canoe that I built. So as you saw, our friend Stackobot here crash landed on a planet, and his friend's circuits got scrambled, and so he has to go run and find his friends and wave at them and bring them back. He's also got to jump on some destructibles, and yeah, he's got to go find his friends, right? Little robot finding his friends. I think it's got Game of the Year potential, personally. And I did it all by myself. This was just me. Nobody else helped. And I think this is really cool. So remember, the totality of the Unreal Engine is vast, and I want to show you stuff that I think is in the realm of possibility for you and how Unreal can empower you. So we're going to talk about some Unreal Engine basics that I think is really important to know when you're getting started, coming to Unreal for the first time. I'm going to talk about how the sample projects and templates can help you get a head start. Then we're going to talk about the in-engine animation tools, so you can stay in the engine and keep animating. We're going to use Blueprint visual scripting and enhanced input to implement an animation. We'll use the procedural content generation framework to populate our world really quickly. We'll use Chaos and Niagara to build our little destructible box. We're also going to use Unreal Engine's meta sounds to build that procedural music system you heard. That was all me. And we'll also use State Tree so that we can drive our little our AI interactions. We'll use Unreal Motion Graphics, the UI system, to add a UI so we can keep track of our number of friends. And then, this is the fun part, we're going to put it on a phone. We're going to get it running on a phone, because this is all stuff I think is achievable for people new to Unreal. So a little bit about the format before we get rolling. This is not going to be a fully live demo. I'm sorry. It is going to be me talking over videos of doing this stuff, because my assumption is that if you are new to Unreal, a step-by-step tutorial the Thursday morning of GDC is not going to be the most useful thing. I'm tired too. So there's probably about 2.5 hours of raw footage that I've sped up and edited down so we can talk about it. But don't worry, this isn't the only time we're going to talk about this. Because the other feature of the Unreal Engine that I think is really powerful is its community. And one of the things that we launched to support that community with Unreal Engine 5 is the Epic Developer Community, which is a website where we host tutorials created by both the community and by Epic Games. There's literally thousands of them out there. And I will have a link at the end of the show to this learning path where I've tutorialized all of the things we're talking about today, so you can follow along when you get home. So, link at the end of the show. All right, ready? Let's get rolling. So let's talk a little bit about the basics. Like I said, it is a big piece of software. And I'm going to try and hit the top 4 things I think are really important to know. Because, like I said, I've gone from Unreal to proprietary to Unreal and back again multiple times. I see some of the challenges that people face. So big thing to understand about Unreal is we have a gameplay framework. It is a game engine. It makes some assumptions that you are going to be making a game and tries to support you. So to do this, we have the object actor component framework, right? Objects are things that exist. Actors are things that exist in the world, and components add functionality to actors and objects. It also makes an assumption that you want a game mode, which is technically an actor, that persists over the lifetime of the level while it's open. And then we have player controllers. That's how we, the players, interact with the world. And then player controller, in turn, possesses pawns, which is our little avatar in the world. The other cool thing that we get with Unreal Engine, when you download it, you get the source code. You can just open the C++ source code, make any changes you want. It means you can write all of your gameplay with C++. It's got some really useful garbage collection features that, as somebody who is a technical artist and not an engineer, I really appreciate. I joke that I am a senior technical artist and a junior engineer. I can write plugins in C++ for Unreal, but I could not write a hello world with a blank Visual Studio to save my life. But if you're not comfortable with C++, don't worry. We've got Blueprint visual scripting that is basically a visual version of C++. And you can do whatever you want. You can do a mix of one. You could do all of one, all of the other, or a mix of both. It's entirely up to you and your comfort level when you're starting out. The other thing we got to talk about is all the next-gen graphics features in the Unreal Engine. We've got Nanite virtualized micropolygon geometry, so you don't have to worry about traditional LOD pipelines. We've got Lumen for global illumination and reflections. Virtual shadow maps are high-resolution shadows that go all the way out to the horizon. Temporal super resolution is a really nice platform-agnostic upscaler, so we don't have to spend a whole lot of time rendering our graphics. We can really efficiently upscale them. And I didn't know where else to put this, but it's important to understand that Unreal Engine is left-handed Z-up. And then this might seem like a weird slide in my top 4 things you have to know about the Unreal Engine. But for those of you who have used the Unreal Engine, right, we've got binary assets, and those assets are referenced by their path. So if I wanted to reference something, I'd go /game/my-cool-thing, right? But if I move my cool thing around in Windows Explorer, Unreal has no way of knowing where you moved it. And so if you move stuff around in the content browser, Unreal is going to go, oh, great. I'm going to put a redirector here, and that redirector is a little signpost that points to where you moved the thing again. So don't move things in Windows Explorer. The other really nice thing about it is in UE5 we've added this. We've added the source control window, so you can do all your source control operations right in Unreal, because we're all using source control, right? Good, good, thank you. All right, that's covered. Let's start talking cool stuff. We've got a number of sample projects and templates to give you a head start when you're making a project in Unreal. So the templates are things that you can make from the little project wizard when you're getting started with a new project. These are included in the engine installation, and they're a great way to get a foundation to build off of for a bunch of different 3C combinations, character, camera, control. So we've got first, third, top down, and so on. And you can choose if you want to do these as Blueprint or C++. So you can kind of compare and contrast the two options. And all of these things can be changed later. You're not locked into one thing or the other. And then if you want to get something a little more advanced, we have a number of sample projects which are downloadable from fab.com. They're more complete projects meant to demo complex systems and the interactions between them. So for example, in the Lyra first-person shooter sample project, we demonstrate how you can very efficiently use Niagara systems to do multiplayer bullet impacts at scale. We also have Cropout, which is City Builder /RTS. And Titan is our newly released open world RPG. And I started with StackoBot. StackoBot was originally released alongside Unreal Engine's 5 Early Access. It has a little bit more to get you going than the base templates, like a character controller with some more mechanics, an extensible interaction system, and several ready-to-use gameplay modules. And best of all, it is all Blueprint-based, so you can jump in without ever having to know C++. So let's go on a journey with our little friend StackoBot. Why don't you wave hi, StackoBot? Well, wave hi to the people, StackoBot. They're kind of waiting. Oh no, StackoBot doesn't know how to wave, but I'm not an animator. I don't have a DCC app on my laptop. I can't help him out here. But oh, it's a good thing we have some in-engine animation tools. So. As somebody who, even in college, studiously avoided rigging and animating altogether throughout my career, I'm really excited about talking about our in-engine animation and rigging tools. So if I am a game designer or something like that, and I wanted to make a mechanic, and I wanted to sort of communicate how that mechanic works, I would maybe have to go talk to an animator or a rigger. I'd have to download a DCC app and open it myself. But the in-engine animation tools let me rig and animate all in the engine. So this first video is me rigging the character. I haven't sped this up at all. There's one edit, don't worry about it. This is the process of me using control rig and modular control rig in the engine to make a rig for StackoBot, all in real time. So we make an asset, make the asset, name our asset because that's what separates us from the animals. And then we jump in and we're going to grab our skeletal mesh. We bring the skeletal mesh in, and then all I'm going to do is take these here modules and drag them onto these here sockets, and that's how I'm going to build my rig. So I drag the spine onto the spine socket. The sockets even tell you what modules you should be dragging onto them. I can grab multiple sockets to duplicate everything over. Very, very handy, very, very efficient. And then I always have to remember that I need to drag the ARM module onto the hand socket. I always forget that part, but the ARM module is full IKFK. We can switch between it, grab the neck module. There was one edit there, don't worry. And then I can just select all the finger sockets and drag the finger module onto those, so I can really quickly do those. So we're at 1 minute and 20 seconds here, almost done. And then we're gonna drag the leg modules onto the thigh sockets. And time. 1 minute, 20 seconds, I made a full rig with IKFK. This is wild to me. I remember when I saw this at GDC last year, it blew my mind. And now, right, I've got a full rig. I can use this rig in the engine, and great, I can make StackoBot wave, right? Now there's more steps. So what I'm gonna do here is drag that rig into the world and use sequencer. It automatically detected that I needed to animate this thing, so it went into animation mode, and I'm just gonna start keyframing. Do I have a professor from my college in the audience right now? Because I don't want them to see, I'm not a great animator, but I do remember some things from college, right? I'm just keyframing the arm here, I'm setting up my key poses, and I can copy and paste those keyframes so I can get that repeated motion, super easy. I select all the spine controls so I can twist them over like that. I'm just gonna move the other arm into place, and then I'm gonna tweak some things around because I do remember that I don't wanna twin all of my movements. I wanna kind of space them out. Don't want everything to kind of happen all at fence posts here. And then what I'm gonna do once I'm done with this is I'll create a linked animation sequence, which means anytime I wanna update the asset for this, I just have to open the sequence, change the animation, and save it. I also make an anim montage out of this, and this anim montage is how we're gonna play the animation on our character. So, right, I used modular control rig to make a rig, and then I used sequencer to animate it in the engine. And this is all within the realm of possibility. This is open to you. So now we need to do something with this animation, and for that we're gonna use Blueprint visual scripting and enhanced input so that we can actually trigger something when we input. So Blueprint visual scripting, for those not familiar, is Unreal Engine's built-in system that combines a gameplay scripting system based on a concept of using a node-based interface to create gameplay elements within the editor. As with many common scripting languages, it is used to define object-oriented classes or objects in the engine, and it fully reflects from C++. And then we have enhanced input, which is Unreal Engine 5's new input plugin that is data-driven and supports things like runtime remapping, and more importantly, runtime management of different mapping contexts, which means you can have different control schemes for different modes without having to build a bunch of if-else statements to make sure that, the W key does something different when you're walking versus when you're driving, right? So we're gonna use Blueprint and enhanced input to play our animation on our character. But first things first, we're gonna make a game mode, and that game mode is gonna allow us to override the pawn that is spawned when we jump in, because like I said, I started with StackoBot, and then I'm gonna use the base BP bot as our parent class because it's got a lot of really good functionality in it, but we're gonna add to that functionality. So we're gonna make an input action, doesn't need to be super fancy, and then we make an input mapping context where I can just click that button there and pick the key that I wanna use. So when we release the left mouse button, it's gonna trigger our input action. But first we need to add the mapping context, and this is really cool right here. So I've got all of the input mapping context that I have for StackoBot, and then in my new class, I can add a new context so that when you click the left mouse button, we'll be able to play our animation just like that. So let's see what that looks like. All right, now everybody wave hi to StackoBot. Get ready. Wave hi to StackoBot. Thank you. So, right, we added a new input mapping context to our character that we created with Blueprint so that we can play the animation we made in Engine, which we made using a rig that we also made in Engine. But you're noticing like there's a bunch of cool stuff in the world, right? But I'm a tech artist and I'm lazy and I don't want to have to go hand place every blade of grass, right? So let's use procedural content generation framework to make the level design itself. Procedural content generation framework is a node-based extensible with Blueprint point attribute generator that interoperates with a bunch of other engine systems. And we're going to use it to really quickly populate our level with ground cover meshes, and we'll also carve out a path for our player. So to get things started, we just make a PCG graph. We do have to enable the plugin. And then that makes a volume, and that's where everything is going to be affected. And then we can just use a landscape sampler, just like this. And what's really cool about the landscape sampler is that all of the different paint layers on that geometry is an attribute that we can filter by. So I'll filter out all of my points for just the grass, and then I'm going to transform those points so I get a little bit of random rotation and scale. And then I can use the static mesh spawner to spawn the trees where there is grass, and then I realized that was too many trees, so I kind of scale it back here. There we go, right? That's it. That's PCG in a nutshell. That was like 4 nodes. We sample a surface, we filter the points, we jitter them around a little bit, and then we can spawn static meshes. Now I've got my trees done. But there's more. From here, I kind of blacked out. Don't totally remember what happened, but I do know that I started to add a few other meshes. I added the bushes, and then I used the difference node to filter the trees out of the bushes so that the trees and bushes don't overlap too much. I added rocks, and then I can filter based on the rotation of the point. So I can filter based on slope, so I can get the rocks kind of going on that, on the cliff edges there. But then I also wanted those cliff meshes you saw, so I filter on a different slope, and I can just press D to debug that and see where all these points are, filter everything out. And then we can spawn in the cliffs. There we go. But then I want the cliffs to face all kind of the same way, so I could send an absolute rotation on them. And then the other big thing that I noticed is that I've hand placed these static meshes here, but they're overlapping with our trees. So what I'm going to do is get all of the bounding boxes of all of the static mesh actors in the world, and then I can project those down to the landscape, and then use these to filter everything out. The other thing that I have to do here is the sky sphere is also a static mesh actor with a very large bounding box. So I do an actor tag on it, and then I can filter out the actor tag for the sky so that the sky doesn't destroy all of my PCG in the level. I also make a blueprint called player path, and it just has a spline component in it, and then I can get the spline data from all of the player path objects in the level and use that to filter out those points as well. Super easy, right? Get some data, filter out the points, and now we've kind of got a pretty solid basis for our procedural content generation. And then kind of behind the scenes, I went through and did a couple of more things. I added the grass and the pebbles, and those are runtime generated, so I don't have to store all of the instance locations of all of the grass blades. Don't worry, I've got the instructions about how to do this in the slides at the end of the show. So, right, that's easy. I made the level. I dressed the level, super easy. But I kind of need to destroy something. I feel a little anxious right now. So we're going to use Chaos, which is Unreal Engine's lightweight physics simulation system that supports things like destruction, rigid body dynamics, cloth, including machine-learned cloth, vehicles, fluid, hair, flesh, and it even does networked physics. So we're going to use this to fracture the box and have it fall apart when we jump on it. So first things first, I grab the crate from StackObot, I go into fracture mode, I make a geometry collection asset, and then I'm going to do a uniform fracture on it, and tweak a couple of settings because I want more pieces out of it. Yep, and do the Voronoi, hit the fracture button, and now, boom, destruction. This is great. I did have to tweak the damage threshold so it fell apart when it drops, but don't worry about that. But I got to do something with this, right? I had to do something with the animation. I have to do something with the PCG. So I'm going to make another blueprint, right? And in the blueprint, I'm going to make a collision box, and we're going to use the construction script of the blueprint to size the collision box a little bit bigger than our geometry collection. And I make sure that I move it up to the centroid, because what we're going to do is detect when something is falling onto the box with this collision volume. So then I do the on component begin overlap. I cast to character. I know that's not the most efficient best practices, but it works for now because I need to detect if the character is falling. And then if the character is falling, I spawn the field system, the master field system actor at the origin of the thing. I trigger it, and then I do a little radial impulse here to fling my pieces out into the world. Easy peasy. So let's take a look at what that looks like. We wave at the box, and then we jump on the box and destroy it. Awesome. Really quick, simple blueprint. Not what I'd do if I was doing like 1,000 of these, but like, hey, it works for what I'm working on right now. So I need to add a little spark and drama to this. So we're going to use Niagara, which is our particle effects system. It is modular, it is extensible, parameterizable. It has a lot of power and flexibility, and it comes with templates to get you started. So we're going to use the omnidirectional burst template to get started here. And I'm going to make a sparking effect, and then I'm also going to add that kind of fiery, poofy smoke that you might have seen earlier. So first thing I'm going to do is kind of orient the particles. Those are going to be really hard to see. I'm going to orient the particles to their velocity and kind of shape them out so that they are, they get that nice sparky long shape. I'm going to tweak the color over time so they start out green and go to red. And then I'm going to name the emitter because, again, that's what separates us from the animals. I'm going to duplicate that emitter for the smoke, and I'm going to make a material. I didn't even talk about the node-based material editor. This thing is great. So I'm going to make a material for our smoke particle effect. I just make a little sphere mask. I'm going to use a noise texture built into the engine. And then particle color is the input that we can get from Niagara down to the material. And then I can get a little smoky effect here. But I'm going to use this black body radiation node, which is really cool because if the radiation of the thing is really, really high, we get those nice orangey, fiery colors to it. I'm going to do a couple of little things here just to tweak that around so that I can add the material to that system. I'm also going to tweak I don't want any gravity on it. I want the smoke to kind of go out in all directions, and I want it to like poof and then grow and then fade away. And I can just shape all of that with these curves here, right? We've all used tangents, right? And now I got that big poof, and then I need to go into the color here, and then I crank the color really high and we get the fire basically for free. And that's our particle effect. So now I go into the blueprint and I created a particle effect component, and we trigger that component when we jump on the box, right? Easy, we've all seen that before. Okay, now we get to, I think, my favorite part of this talk, which is meta sounds. So how many of you call yourself like a tech artist, or you've used node-based shader editors before? Okay, like half the room, give or take. So what if you could have shaders for sound, right? Seems interesting. So Metasounds is a high-performance audio system that provides audio designers and you complete control over a digital signal processing graph for generating sound sources. It is a fully procedural audio engine offering sample-accurate timing, which means audio can be scheduled at a resolution of 1/48,000th of a second, which is wild. And we're going to use this to make our really cool procedural music system and make it reactive to our player. So if you've ever used a digital audio workspace or done any modular synthesis or chiptunes, this is going to start to feel really familiar. I'm making a patch for those of you who understand that. So a snare drum, we're going to start with that, is just a filtered white noise. And I tweak the frequency on that filter there, and I'm not going to demo what white noise sounds like. I don't want the audio guy to hate me. But then I want to like play this sound, right? So I create this trigger repeater, and the trigger repeater is going to play on a period based on a certain beats per minute. And then I'm going to use an envelope, which is just a curve that we have control over. So I tweak the parameters of the curve, the attack, how quickly it ramps up, the decay, how quickly it comes down. And we're going to multiply that over our audio here, and then we can plug that into our output. And now we have a snare drum that plays on the quarter notes. Yeah? Right? Super simple. Okay, let's get a little more complex. I'm gonna, the hi-hat is basically the same thing as a snare, but we're gonna play it on the 8th notes, and I'm gonna tweak the parameters here, add a tiny, tiny delay to it. Great, that's my hi-hat. And then I'm gonna play the kick drum on the 1s and the 3s, and this one's really cool. We're gonna modulate the frequency of a triangle wave, because really the kind of foundational thing here is waveforms that we envelope. Right? That's all we're doing. We're enveloping waveforms and playing them at triggering them on a certain frequency. And then I can mix all of these things together. And what's really cool is inputs into the graph make those little knobs. So now we can put all that together and make our kick drum, or make our drum kit. So there's our kick drum. And what's really cool is I can play these, I can tweak those knobs as it's playing and previewing in the editor. Awesome. right? So next up, I'm going to build a synthesizer. I'm going to start out, actually, I'm going to set myself up for success here and make my final mix, just to make things a little easy on myself. The other cool thing is inputs and variables are namespace. So when you make a new variable, you just do thing.thing.thing, and it'll namespace it really nicely. For the synthesizer, we're going to play one tone over the course of the bar, a whole note. And for this, we're going to randomly pick a note between 60 and 72, and then convert that into MIDI, convert that into frequency, and play that on a square wave. And so this is going to give us a nice long tone over the course of the bar. And then, so we pick a random note between 60 and 72, I output that note to a variable, and then to play the melody, I'm going to add an offset to that note. So whatever tone we're playing over the course of the bar, we add a couple of different numbers to it, and then we can get something that's kind of related to the sound that we're working with to start. So then we can mix those two together. We've seen all this before. And then here's kind of what that sounds like. Here's the bar tone. And then we'll mix in the melody. Right? I didn't have to write a single line of music. I just had to make a couple of nodes. Now we'll mix in the drum kit. I am not a musician, but I made some music, right? This is pretty cool. And then I showed this to our audio director, and he was like, hey, I've got a couple of things that I want you to do to really punch this up, right? Because we can make this even better with a few simple things. So, right, it was really repetitive, right? I'm playing on the whole notes, the quarter notes, the eighth notes, and so on. And so the thing that I'm doing here to kind of punch this up is I added a 16th note trigger, and then I trigger this trigger filter here, and it has a probability of 30%. So there's a 30% chance that we're gonna roll heads. So we combine those two triggers together, and what this means is basically every 16th note, there is a 30% chance that I'm going to play an additional note. And that gives us a little bit more kind of variation in our tune. Then the other thing that we do is a really quick and dirty trick to make it stereo. So I've got the stereo mixer here. I'm going to put that out to the final output. And then I have this, here's the compressed output of the kick drum, of the drum kit. And then to do the left channel, we just plug that in. And then to do the right channel, we just delay it by 0.01 seconds. And we get really quick and dirty stereo sound out of this. I did some other stuff in here. I'm going to talk about it more in the Epic Developer Community article. I do some stereo delay and panners. I found out what a flanger is. And I blacked out. This was a lot of fun. And I really hope you have a lot of fun with this too. And then when we put it all together, what we end up with, oh, and then this was really important, right? We have to do the blueprint. So I wanted to update the beats per minute based on the player's speed, right? So I've got this beats per minute input here, and then I trigger this float value to update the internal beats per minute on the whole note. This is really important. So every bar, we're updating the beats per minute. We're not doing it right in the middle of a bar, because that would sound really weird. And there's a couple of things we need to do to make this work. So I made a MetaSound patch, and if you're familiar with the material editor in Unreal, this is basically a material function, right? If a MetaSound is a shader for sound, this is a material function. And what I'm doing here is just a trigger compare. So when A equals 0, we'll output this, and I've just got a count, and we're gonna count up from 1 to 16 every 16th note. And every time our divisor here is modulo equals 0, get the remainder, we output the trigger. So if the divisor is 1, here's what that whole block looks like. If the divisor is 1, we're going to trigger that. That's the 16th note. If the divisor is 2, that's going to trigger every other note. That's the 8th notes, and so on and so forth. So this lets me do a kind of really simple system for outputting all of our triggers only have to update the beats per minute once. So that was really fun. And then I make a blueprint. Again, blueprint keeps coming up. So I make a blueprint where I play the sound, and then on begin play, I get a reference to the player character. And then every frame on event tick, it's okay, I can use event tick. I get the player speed and then I kind of use the player speed that I normalized to pick between a low beat per minute and a high beat per minute. So when we're standing still, we're kind of lower BPM, and when we start moving, we can crank that up. So here's what that all sounds like. Oh man, that sounds really good in here. So yeah, right, I'm holding still, slowing down, and then we start moving. Right, at the start of the bar, we start playing that a little higher. Like I said, I had so much fun working on this. I tried to keep it accessible. It may seem complicated, but like I said, don't worry. MetaSounds can still do all the stuff that you're used to, right? We can play sound files. It's all deeply integrated with our tools. I can make presets based off that graph. So if I wanted to have like 3 or 4 different songs or different values, I could do that. And I could have spent hours more on this, but I only have an hour to spend with you today. So let's move on to state tree. This is how we're going to drive our AI. And the state tree these are a really fun thing. They are a general purpose hierarchical system that combines the selector logic from behavior trees and the state transition logic from finite state machines. And this is what we're going to use to make our little friends that wander around until it sees us, and then it's going to go run and hide until we wave at it, and then it'll follow us around. So off camera, I did a little bit of setup. I created the friend blueprint, made an AI controller blueprint, and now I'm making the state tree. And to get started, I'm just gonna do the idle wandering state. So when we idle, we're gonna idle for about a second, and then we're gonna wander around. You can also colorize the different states in the state tree, which I highly recommend. In the AI controller blueprint, we'll add a state tree component and trigger the logic on start. So now I'm just kind of like looking like, hey, that thing actually worked, because I could see the debug text on it, right? And then here I'm making a state tree task that is going to give me a random location in a navigable radius. And you use the categories to output the values over here. And then I can bind the output of this state tree task to the destination input of this move to really quickly. It just goes boop, boop. And this is how we're going to wander around. Right, so now the friend is going to go wandering away, and then it's going to idle, and then it's going to start wandering again. Easy. Next, we need it to run and hide when it sees us. So I make a really simple blueprint component that detects the player character. So every frame we're going to see if we're in radius, and then if we can trace to the player, and the first thing that we hit, if the first thing we hit is the player, we're going to send an event dispatcher out so that our AI controller can detect when the player is detected, and then pass that information onto the state tree through a state tree event. And then we're going to add a payload to it, which is just a struct, so that the state tree knows what character we detected. Now I'm going to start setting up the hiding state. So first thing we're going to do is try and find a hiding spot, and then we're going to go to the hiding spot, and then we're going to hide at the hiding spot. And if we fail to find a hiding spot, we're just going to cower in place. Right? Makes sense. So to find the hiding spot, what we're going to do is use the environmental query system to scatter a bunch of points, and that's going to come up in a second here. There we go. Looking at my homework. And then we're going to use the environmental query system to find that point. And this is a really, really clever system here. So I'm going to scatter a bunch of points around the querier, which is our player pawn, and then we're going to trace from that point to the player. So if the player can see that point, we discard it because we need to hide from the player, right? And then we detect if we can path from the pawn to that point, right? We can't go hide somewhere we can't reach. And then we rank those based on the distance to the player. So I've got my friend, they're over there. I turned on the debug view so we can see what happens with the environmental query system. So, right, our friend can't see us right now. We're not in radius. And then as we approach our friend, there's our friend. It spotted us. And the environmental query system is what scattered all of these points around. And we can see all the ones that are in green are the points that the player couldn't see. And then they're ranked. You can see kind of a ranking value here based on their distance to the player. And then we ran to that point. And now we got to get our friends back. So We're going to make another state, which is the friendly state, and we're going to transition to this when the player waves at us. So, and then we also want to follow the player around when we're friendly, right? So I can just say, hey, we've got this detected player value that's on the AI controller, and that's the actor we're going to follow around. And then I use another state tree event. We'll trigger another state tree event when we get waved at. That's what this make friend function is here. So we'll send a state tree event that says, hey, now we're friendly. And then in the player blueprint, when we wave, we're going to do a sphere trace out from the player in the direction of the camera. We've all done a little bit of vector math, right? So we're going to trace out from the player and detect all of the, if we overlap anything, and those are our friends, then if they're not a friend, we're going to make them a friend, right? And then I'm also going to, in the blueprint, I'm going to change its color with a material parameter override. And now we've got our friend. They couldn't find a hiding spot, so they're cowering in place. And then we can wave at the friend. Yep, there's the environmental query system again. So we'll wave at our friend, and now our friend is our friend. Huzzah! I did it. But I want to keep track of my friends, right? I got this weird thing. I got to keep score. So we're going to use the Unreal Motion graphics system to make a quick little UI so we can keep track of our friends. So Unreal Motion Graphics, or UMG for short, is the engine's blueprint-powered componentizable visual layout and design tool. You can even put materials on UI elements, which I think is really, really cool. So this one's going to be a little lighter weight, but I'm going to keep track of the number of friends that we have in the game mode here. So when we make a friend, we'll tell the game mode that we have made a friend. And then I'm going to make a really quick little widget here. It's just a horizontal box with an image and a text variable. And then we're going to make a little function so we can say, hey, you should update the number of friends. This is a sort of straightforward way to do it. We have a more involved and systematized way called model view model. We'll talk about that later. But yeah, when we make a friend, we increment the number of friends. The game mode is going to store the widget, add it to the player, and then update the widget when we make a friend. So now we can see in the upper left corner, could have made that bigger. There we've got our little friend counter. Yep, now we're adding friends. Fantastic, that went up by 1. They get really close. I need a little space. But yeah, now I've got all my friends. But I really wish that I could share this with all of you. I wish all of you could play this, and I can't give that to all of you on that laptop there. So I really wish that I could get this running on a phone. There it is. This phone. So there are a couple of really good tutorials for this, but we have a lot of built-in tools to make mobile development easier for you. You can preview in the editor, you can deploy directly to a device from your computer. There are some great instructions on getting set up for Android development. I'm not going to go over those right now. I will have links for those in the tutorials that we've got later. But yeah, I did a little bit of scalability so that when you go onto, this is a Galaxy S10, it doesn't melt the device. And here's what that looks like. Right? I recorded that from this phone. And we've got virtual joysticks so that we can, control it on the phone. I also added a couple of buttons to that. So I've got a button to wave at our friends. I've got a button to jump. And I got it running on a phone. And this was really straightforward. Actually, one of the really cool things that we've added recently is when you package for Android, there's a little batch file, and you just double-click the batch file, and it pushes it straight to your phone. So if anybody wants to play my Stackobot Odyssey, come see me after class. So, what have we learned today? Well, we learned some Unreal Engine basics like the gameplay framework and using C++. We used a sample project to give us a head start, get us up and running. We used the in-engine animation and rigging tools to make our own animation, which we combined with Blueprint and enhanced input to make a really simple waving mechanic and animation. We used PCG to help us populate the level. And we combined Chaos and Niagara to make a really fun destructible. We used metasounds to bring texture and to a life to our auditory experience. We used State Tree to help us make a friend. And we used UMG to keep track of our number of friends, which we were able to deploy to a mobile device so we can test there as well. And that's hopefully enough to get you started. There is a lot more to explore. These are a bunch of the slides that I cut because I probably didn't have enough time. Systems and the game instance are really, really useful if you want to get more involved in your gameplay setup. Interchange is really useful for automating your import-export pipeline. We didn't talk about contextual animation or motion matching. Or I briefly mentioned model view model, but is really helpful for building systematized UI. Common UI also for building UI. We didn't even talk about multiplayer if we wanted like multiple friends to be competing for more of our friends. First-person rendering is a really cool thing that we've started to add recently. Scalability, I briefly mentioned it, but that is a whole separate talk. World partition and streamings, if we wanted to have like a big 16-kilometer open world. And because I am a tech artist, some of the things that I love are editor scripting and the scriptable tools framework, which are both blueprint-based, so we can write our tools in the engine with blueprints. We also didn't talk about the modeling tools. I could have made the models in the engine or used geometry script to procedurally make those models. It was wild. There is, of course, so much more to learn. My colleague Ari Arnbjørnsen did Setting Up an Unreal Engine Studio the Epic Way and Myth-Busting Best Practices in Unreal Engine. These are required reading. Required. We also have a great series on the Epic developer community called Begin Play, which is meant for experienced developers who are coming to the engine for the first time to kind of translate that layer. I also wanted to highlight the game animation sample. It's great. And there is a lot more to see today. So coming up next, Arvind is going to be talking about mobile development workflows with the Unreal Engine. And then after that, the inimitable Chris Murphy is going to be talking about preempting challenges in AAA development. So if you saw some things that you know are not best practices in my talk, check out his talk. He's going to have the answers to that. And then finally, if you want to learn more about chaos destruction, my colleagues Jim and Cedric are talking about that at 3:30. I also wanted to highlight, again, one of the best things about the Unreal Engine is its community, and we have the Epic for Indies community. You are welcome to scan that QR code. It's a great space if you're looking to connect, ask questions, share progress, find support from Epic and our partners. This is great for the independent developer community. And with that, thanks.